So let's just move down to your area. Oh, sorry. A second. That wasn't supposed to happen. Right. Patrick's Day stupidity kicking in. Right, folks. I'll do a nice handy one for you today. It's called um, planning the work activities. What I'm doing now is gearing you up for your final group assignment and the Lemming TV case study that you're using as your data input to build your assignment, team assignment. So we'll quickly go down through these planning. So again, bearing in mind that the Lemming TV case study is literally just a chunk of text, and in that it identifies activities and things and work packages that have to be done, and we just need to extract those. And this is where I'm coming from in this one. Now, next week, what I'll do with you, we'll go through the actual case itself. This day next week, I hope. That would probably be the plan, and talk you through how to go about it and what to not so much how to go about it, you know how to go about it already, but to just bring some of the finer points, because I'm sure there are some questions that you have how in this, and this is going to start should we say the ball rolling, or giving you a bit more insight into it. Is that okay for you folks? Yeah.
Yeah.
Okay, I assume so. Anyone like to put on any cameras now? I can't. I'm looking at blank screens here. Names.
Actually, my internet is kind of weak, so I'm not able to turn it on.
Sorry.
My internet is kind of weak today, so I cannot turn it on.
I know. Yeah, exactly. I earlier on I was using. I'm on Vodafone and I couldn't even make phone calls for whatever strange reason. But fortunately, I've had my whole system upgraded there a couple of weeks ago. So it's yeah. Anyway, we're getting there. Right, folks. What I want to do, I'll fly through this. I don't expect to hold you for the full 2 hours anyway. So we'll start moving on this. So what we're looking at, initial project coordination. So early meetings set up to decide what are the projects. So we begin to kind of get a feel for what our requirements are, what's the scope of the project. So we get the bigger picture, and that's what we mean by flesh out the nature of the project. What do we think we want to do? Whether it is introducing a new product, new product introduction, as they often say, or a new service introduction, a new feature, or as I say, a complete new product, an add-on to an existing suite of products. Whatever the case is, we have some idea. We might decide that we're introducing a new generation of our products, and that's the bigger picture. So we need to sit down and let's flesh this out. What do we need to put in place? So we look at the technical scope. What technologies do we need? What kind of technical people do we need? The equipment, and processes and materials and so on. And one of my latest examples was a company called Lore, Lore, and this company is a new player in the cycling apparel industry, and specifically into cycling shoes. Now, if you're familiar with cycling shoes, you're probably saying, geez, do we have to listen to this guy again talking about cycling? Yeah. But the point, cyclist shoes are they're either very tough soles on their shoes. They have to be for pressure and power and all that. Normally, the mid to high range cyclist shoes are made from carbon, and the uppers could be made of other fabrics and so on. And if you want to have really good expensive shoes, you're looking at somewhere around 400 or 500 euros for carbon, light carbon, and uppers that are comfortable. They'll have some level of fitting for the insoles and so on. So they're expensive and light. That's the whole point about it as well. Latest versions that are available on the market are about €450, and they're made by a company called Specialized, which is an American-based company. And they have a slight change, and they use a bit of a sock inside for more comfort and spread of foot. So you try and get the as much of a natural feel as possible, but nice and tight. So you're tied, you're connected to the pedal very strongly. Okay, but this new company, Lower, you can consider them to be a potential disruptor. And the reason why is that they've now developed a 3D printing process using carbon fiber, to customize shoes for each individual. So I'm not sure of the process because it's quite new, but all they're saying is that yes, we can take measurements of the foot, we can take 3D measurements and so on of the foot, and based on these measurements, they can construct a one-piece shoe, uppers and lowers, so there's no adhesive and anything like that, and they encase it with a final layer of not so much fabric, but a kind of a carbon that makes it look like almost like a sock that you're on your foot. Now that's what they're offering, and again, it's their USP. If you think of your business model canvas, their unique selling proposition is that it's customizable, highly customizable. Today, if you were to buy a highly customized shoes, you're looking at €3,000 to €4,000. Very high end stuff, extremely light, perfectly made, customized, but that's outside the reach of most people. So these guys looked at the when they fleshed out this whole market and said, hang on a second, there's a real opportunity here. If we can produce highly customizable, lightweight shoes, there is a huge market out there because there's all the non-professional cyclists who use these. Okay. So the technical scope, they brought people from Tesla, IBM, Nike, Puma, and where else? There was a couple of other non-sports companies. I can't remember where else. They brought these types of engineers and product designers together to come up with a process and the techniques to do it. So they did all the technical scoping, and then looked at they had their own areas of responsibility. Some will be into graphic design, some will be into materials. I know there was a couple of physicists involved in that company. So watch out for this company. They're actually going to launch their concept in April of this year, at one of these trade shows as such. But the interesting thing is, as a company, they've never existed before. They're brand new. So this was a brilliant project that they've embarked on to develop something that's different from what's already available. So but it's the way they're doing it, the technology they're using as such. So these guys were sat down and said, there are new equipment, there's new materials and so on. So let's now try and pull all these together and develop a product for which we know there is a market. So you have your business model canvas, they know there's a market out there, they can analyze the level of demand for that high-end type shoe. If they can produce this at an affordable price, which they believe they can, then they're going to make an absolute fortune. So areas, and then delivery dates are budget notes. So they start looking at, how much is this technology? How do we access our customers? Do we have to have equipment in every shop, or can we develop technology where we can take the measurements online? So for example, do I take a photograph of my foot? Do I download a template of my foot size and put my foot on this with all these squares on it and say this is the size, and take a 3D dimension? Now there are already 3D scanning machines out there. They do it for headshots and so on, and sometimes for BMI, your body mass index. They can work out these, they can replicate you in a 3D model and so on. So they might use something like that, or have them in dedicated bike shops and specialist shops and so. I don't know, but these are the kind of things that these would be they're thinking about already. So they'll most likely have more advanced technology for taking measurements and so on. So the risk management group is created. So they look at this, well, what if this goes wrong, if we can't deliver, if we expect that there's going to be a high level of demand for a product, how do we meet all this demand? Of course, we can charge higher prices, but if we do that, the demand would fall off. So getting all this right. So this is where we look, and what if delays, and bearing in mind that this company has come so far that they've gone past the prototypes, they've gone past the well, they're at the prototype stage. Now they're looking at the mass production, so to speak, of customizable shoes. So they would have done all of these activities in the early days to make sure they were on the right tracks. So each participant in the project should approve the initial plan. So once all the technical people there and the finance people and marketing people have sat down and looked at this and say, yes, from each of our different perspectives, this all makes some sense to us. So we have a high level plan. Bearing in mind, remember, the Meteor methodology that I showed you does exactly this. So we have a high level plan. So senior management approve it, or the company sponsors or project sponsors, they approve it. So and as I say here, for example, senior management may change. They may want to speed it up. They may want to reduce the budget. They may want to, part of the budget might be held back for contingencies. So the senior management will say, right, the information that the project management team and the project manager has presented to me in this initial plan, could we do this in 9 months instead of 12 months? And as the project manager would be the competent person in the room there that has all the details, will say, only if we increase resourcing here and buy additional equipment there can we reduce the time, so it comes at a cost. Do you remember this famous little diagram? Time, quality, and the cost. You have to weigh the quality being the performance and how quickly you can get it out, or the length over a period of time, delivering quality, all the requirements. Or we could say, well, we can reduce the requirements and we can only take certain types of customizable shoes for one particular type of pedal, and we can release them and then do the next type of pedal, and so on. So they could look at ways of trying to reduce the scope of the project such that they can accelerate time. But these are the kind of negotiations that will go on at the earlier phases. So the outside clients in many cases, so when it's for outside clients, if you're developing a product, specifications cannot be changed without client's permission. So if, for example, that company decided that they were going to subcontract the manufacture of the shoes, or the design and development of it, they'd have to be quite explicit to that company. This is what we want. So the company running it as a project, this third party company, would have to do exactly what the client requests. Okay, and that's generally the case with most projects when you're delivering like a large telecom system to a telecoms operator. We'd have to listen to what their requirements are, understand them, and say, well, we'd like to change this. You can't do it unless you get the client to agree to it, or you explain that there's some technical reason why you need to do it differently, or not do it at all because the client may not be aware of some stuff. So and then the client may put a budget constraint on the project, which they usually do, and say, based on the information you provided, we're willing to pay X amount. And if you go beyond time, there's a penalty. If you come in ahead of time, there's a bonus. And they may be competing against other firms, of course. So when you're producing, if you're running the project, or the ordering company has asked you to develop a project, a product or service or whatever for them as a project, you might be competing against other firms that are looking for your resources as well. So there's a lot of constraints and how to say, I won't say interferences, but competition within. That's why we talked about the rivalry amongst competition. So you also have rivalry within an organization for project priorities as such. So we have to be very clear on those points. So then as we move on, we start to bring together the project proposal. So when we've gone from the initial plan down through the detail, and if you remember on the methodology I showed you, we have the feasibility phase. So as we go through the feasibility, we're starting to investigate more in detail the requirements, the resources, the people, the time scale, and so on and so on, and the activities, each of the activities that must be done, the critical path, and so on. So we get to get a more realistic project proposal or project plan, and it's at the end of the feasibility phase. That's when we have literally all the data, all the information, and now we can make a more informed decision about going ahead with the project or not. We may find at the end of the feasibility that some elements or work packages or activities cost an awful lot more or are more complex to implement. Therefore, what we initially thought might be 9 months at a cost of 1 million euros, it's now going to take us 11 months at the cost of 1.7 million euros because we found issues. We've done all the assessments, the risk assessments, the analysis, and so on. That's why the feasibility or the planning phase is so bloody critical in organizations. And as I say, 80% of projects fail in that part of the project. When we analyze backwards what went on the project, we didn't plan properly. We didn't have all the activities. We underestimated certain activities. We overestimated other activities. We changed the scope. We did all these things, and we should have planned more carefully at the start. So elements similar to general planning components. So the project plan elements, we have an overview of the project, the scope of the project, all the requirements, how we're generally going to approach the project, any contractual aspects. We need to deliver part of the product or part, at this phase, and the different deliverables from each phase of the project. And then when we'd have the final product or service available, these are all contractually agreed. Of course, we have to have the schedules to support when we're going to deliver these. The people, the resources being the equipment, any new technologies or existing technologies that we need to use, and of course people, the risk plan if something goes wrong, and evaluation methods, the monitoring and control. How are we going to monitor and control the project? At what stages? That's why we use these methodologies with the various milestones and toll gates. So we have end of feasibility, that's the end of one toll gate, and that might be milestone 3 or 4, and then we go into the next phase, the design and execution, and then the next phase, test, and so on. So each of those major phases will have subsets inside them. So we talk the major phases are toll gates, we sign off, and interim checkpoints are called milestones. So these are the evaluation methods, and that's where the likes of your earned value management becomes so important, so we can see what's happening in real time virtually to be able to take corrective actions. So it's all about control and monitoring of projects once you've gotten the detailed plan in place. So what's in the overview? Short summary of the objectives and scopes of it, and directed at the top management in your organization, those that are going to prove it, and includes objectives, organizational structure, and major milestones, which I've just spoken about. So the organizational structure: who's the project manager, who's the technical manager, who are the various teams working on the project, from what backgrounds they come. That gives you like an org chart within the project itself. Of course, you have the requirements and the clear specific objectives or work packages that need to be delivered. And then the objectives or scope of the project, more detailed statement of the actual goals, includes the goals on profit, competition, and technical goals generically. So we'd say based on all of these costs, we expect to make a profit of X amount, and any overrun in the project will eat into that profit. That's why the control and monitoring becomes so important, to make sure that we stay profitable. Because if you run over your costs and you start eating into your profits, you can't go back to your client and say, I need more money because I'm not making enough profit. Tough luck, you're a loss. This isn't the children's hospital. Starting off at what, 700 million, 600 million or something like that. Now it's running into potentially a cost of about 2.6 billion euro. Scope creep at its absolute worst. So project plan elements, the general approach, so the management and technical approach to the project. So they may have a technical section to discuss the project technology, and may discuss the use of subcontractors. So again, just generically, so certain, you might have, say for argument's sake, that in you're developing components, you may not have in-house specialists to develop to design the component or some parts of the components. If you were developing a new engine for a car, you might need to get a product engineer, a product design engineer, or a product design engineering company to design some part of the engine to make it fit better, to perform better, and so on. So you might subcontract because you don't have the in-house expertise. And that's very, very common, you know. Or you might go and say, look, this is our existing possibility or prototype or idea. Could that be refined and made more efficient or smaller or made from different materials? That's why you go to these specialist companies, materials research companies, or product design engineering companies. They exist all over the place. But these would be the likes of subcontracting, or you may have to have very specialist equipment. Say, for example, in the shoe company that I talked about, 3D scanning, for example, is there a specialist company that has the machinery that can do 3D scanning, that clients or customers can go in, have their feet scanned on this machine, and they can send that information back. So you could subcontract to these companies part of the manufacturing process, so to speak. And so they become subcontractors. So you have to be sure that they can deliver the volume, the quality, and so on that you require for the end product before it goes back to the customers themselves. So if we look at the contractual aspects of the project, you know, how you're reporting it, and as I said, the biggest problem you would have is you start your project and you don't go to your customer until the project is finished. Whether it's 6 weeks or 6 months or 3 years, you need to involve the client or potentially your customer or your sponsors. So that's why we have progress reports, and these are the reporting requirements. They could be fortnightly, it could be every month. Unlikely that they would do it every week, very rare, but generally speaking, the size of the project, if it's over a couple of years, it's generally monthly reporting. And this is what we need to put in place. So where do you get the data? Who provides the data? So to make sure that, you know, engineers working on it, all the various people working on that, they fill in timesheets timely. Maybe they do it once a week and you take 4 weeks and that's your month, and so on. Customer supplier resources. Who's supplying your raw materials? Do you have the contracts in place? Do you have service level agreements in place with them? Liaison arrangement. Who interacts with these external organizations, such as suppliers or retailers, and so on. Advisory committees, yes and no. It depends on the scenario where you might need advisory committees. In some very large organizations, they have dedicated project management structures where they might have a team of project managers who can come in and audit your program. Now, that is covered in another lecture, but it's a very small point, really. But sometimes we get second opinions, so to speak, from them. Project review and cancellation. So at what stages? These are the toll gates. And the go, no go, that's a cancellation. If we decided at the end of the prototype phase that the market isn't ready for it, we cancel the project, we stop it, we pause it. Or we might find that a competitor has beaten us to it, so now we stop, we don't keep going. Or we might keep going because we might be able to come in at a slightly lower price and still make profit on it. But we have to have that tough decisions have to be made sometimes to cancel or to go forward. But as long as we have sufficient data and the right data to be able to make that decision, that's important. Proprietary requirements, if there are anything specific to the company that are to the project that you need, certain specializations, expertise, or special equipment that needs to be developed in-house, that's proprietary stuff that you need, and that can be very valuable to you insofar as it could underpin some patent in the way you're developing the product or using materials as such. And then specific management agreements and so on, you know, with the in terms of, for example, reporting and budget and costs. So if we go on, then, you know, the schedule, it's a list where each task will be completed. And a schedule is basically the start, finish of the project and all the activities, the work breakdown structure, and each of those activities that, as I said, the finite level is an activity that one person carries out. After that, it could be an activity that 3 or 4 people or 10 people carries out. But the lowest level, you keep breaking it down and breaking it down and breaking it down until you have one person per activity or part of an activity at least. That's the lowest level, and that's when you can be confident that you've done all the planning. If you say, "Oh, I'll take 100 people to develop this new product," what 100 people? Where are they doing? What are they doing? How are they spending their time? You need to be more specific. I need these engineers to do that part. I need these engineers to do this because they're a different type of engineer. I need these marketing people because we're going to use them online. We're not going to sell directly. So you need to be more specific. So we break it down to the tasks. Then you have the right people at the right quantity and the right competence for each task. And then is the heart of completing. So that's scheduling is the heart of completing the project. So when you've completed the schedule, then you can take a breath and say, yes, now we know what precisely has to be done, by whom and by when, because we have our plan, the schedule and all the activities, and everyone is assigned. We know what equipment we're going to use. That's the level you need to be at the end of the feasibility phase. You might have still some question. You might not have precisely identified every person. You might say, well, we need to get someone to work on that activity, but you have most, if not all, of the schedule done. Then, of course, the resources, when we look at these activities, the number of people and the materials we need and to do per activity or per task. So the cost monitoring and control procedures that are put in place. That's your earned value management. That's where you gather all the information. You're monitoring the actual versus the schedule or the plan, the baseline plan. Personal requirements for the project, skilled and listed rather than people, and then may include time phasing of requirements. Simply what that means is some requirements, it's like the critical path. You have certain elements that might not be on the critical path but are needed to be done earlier in the project rather than later. So otherwise they get overlooked or forgotten about and so on. So the time phasing and the real time phasing is the actual critical path itself. So we make sure we have this piece done because it feeds directly into the next piece. If we don't, and if there's a delay here, then there's a delay potentially all down along the project. So getting all that time phasing, because you might have, for example, 2 activities that are not on the critical path. You can't run them side by side because the one person needs to work on each of those activities. So you might just have to phase them out and say, well, move them out to one follows the other. They're still not on the critical path. Therefore, Mark can work on that part of the project in week 4. And when he's finished that in week 7, he can come on week 8 and do the second part, because we can't pay. There's no point in trying to get Mark to work overtime because it becomes more expensive, because it's not critical that they're produced all by week 7. Do you see what I mean there? Yeah. So if we look then, the risk management problems and lucky breaks. Do you have lucky breaks? You do. And you also have luck that goes against you. Sometimes Mark is in great form and he does his activities and he gets them completed faster than would be expected. So you get a little bit of a bonus insofar as that what we thought was going to take 2 weeks only took a week and a half. Now we can do that second activity slightly earlier, so we free up Mark, and maybe we need him later on in another part of the project, for example. That might be a lucky break, but also we have, if there are potential problems, we need to identify those. So again, critical items, critical path elements. So evaluation methods that we look at in these: what will be measured and monitored, how the data will be collected and stored, and how the project will be evaluated. Again, without going into each of those in absolute detail, we've spoken about it before. How do you collect the data? How many hours have been worked per activity, recording this information, whether it is a time recording system, whether you physically go down, ask them how much time have you spent on this, and take note of it, and so on, so on, so on. It's the ease at which the data is collected. Now, bearing in mind that you only need to collect data that's important, so you don't need to know how much time I had off, or do I not work after 4 o'clock in the afternoon or something like that. You just need to know how how much time I'm spending on the actual project. If I'm working on 2 days a week on this project and the other 3 days, you don't need to know that. Just the 2 days, and am I getting my work done the 2 days? So having the right recording system in place, and it has to be easy to use. Otherwise, people won't fill in the information if it's too complex. And God knows I would have seen stuff that we used to use in paperwork years ago in multinationals. And now I'm going back a long time, but that's how it was. Um, now it's literally just a clock card. In some cases, it's where you position inside in the building through geosensors and so on. So the systems integrations, we need to have the performance, effectiveness, and cost. So quality, time, and performance. So the action plan, what has to be done, when it's to be started and finished, start dates, end dates of each activity, and who's going to do it. That's the assignment. That's the action plan. So you have the schedule of activities. Now you assign the people and the start date. So you're getting into the real nuts and bolts of the project itself. That's where the likes of Microsoft Projects helps you. So we know that this activity starts Tuesday morning at 9:30 and finishes 3 weeks later on a Wednesday afternoon at 4:30, for example. So you can see that bar going across, and then you'll know that, oh, there's 2 weekends in there, no one is doing any work, so we discount those. So we'd set up that we have a normal working week, 8 to 6 o'clock or 9 to 5, they're the allotted hours available to us. And outside of that, then it's a bonus. It can be a lucky break that you might get someone that will want to work at the weekends because for whatever reasons they want time off later on in the year. So you get them so you can get a lucky break. In that sense, it depends. So the action plan, so the activities on the project face unique complexity. So some activities cannot start until others. That's the critical path. Some activities must be done at the same time. So some activities are very time critical, and others have a great deal of flexibility. All this is just saying is what's on the critical path or not, and the importance of, and those activities that are, for example, activities that must be done at a particular time are on the critical path. Any delay in them will delay the project, so you will have to monitor those more closely. Okay, that's the bottom line on the criticality of certain activities. So knowing all this requires a great deal of planning, and that's the point. You need to be absolutely sure that this is the critical path. Technically, we know, and therefore time-wise. So when you have all of that done, you have your detailed plan. So the hierarchy of planning. So major tasks are listed. Each task is then broken down into more detail, and this continues until activities can be completed are listed. So we need to know which activities depend on other activities. So that's literally the best way I describe that is if you buy a piece of furniture in IKEA, they have a diagram and you'll have the completed item. Then they'll break it down into, these are the drawers, for example, if it was a cabinet. Here's the drawers, and then for each drawer they'll show you there's three sides, a front part which is the fourth side, and a base for the drawer, and then it might break it down. The front part has these additional, so it breaks down. It's literally like a pyramid or hierarchical structure. We would have had them years ago when we were making aeroplanes from Aerofix. It's in manufacturing terms, it's what's known as exploding the bomb. Okay, bill of materials. So you could see the completed car, and then they'd extract the car out, and it's see wheels, engine, dashboard, gearbox, suspension, and then you can break down to the suspension. That's all this is talking about, a hierarchy. You'll see one coming up now shortly. So we have the action plan, which is a form to assist in planning. What are the tasks? How many people? What do we think? Is there a predecessor? In other words, is there something you need before you can do that task, and so on. So that, now these are all automated. We wouldn't be physically using these. Generally speaking, we wouldn't. That's just a breakdown of a career day. It's small enough on the screen so I can't even see it, but it gives you an idea of what has to be done. So, for example, if we were working inside an AIT, we do have career days. There's a hell of a lot of planning goes into that. We have to arrange with marketing, we have to arrange with lecturers to volunteer to come in and talk, and we have to set up tables, we have the structure, we have to choose the hall, usually in the sports arena. Then we have to have the four faculties inside there: science, engineering, sports, business, and then each of those have to be broken down. So there's a lot of planning goes into that for one day. It could be, a couple of months of planning. Only a handful of people at first, maybe the heads of department and marketing, and then more and more people become involved, and more functions in the organization, because you have all the facilities people, you have the marketing people, you have the lecturing people, you have non-lecturing people, you have involved. So everyone comes together. You have the counselors coming in, you have the career guidance people coming in from the college. So we start to build out and flesh out the team and all the equipment that's needed. And if we were to, for example, if the engineering people wanted to show what they can do with virtual reality, they might have to set up specialized equipment. That's the kind of stuff. So who's responsible? Once you have a task and you have a person's name responsible, then you can pretty sure things get done. Okay, that's a kind of a schematic. This is something like the product breakdown that I mentioned. Now I'm going to keep going, folks. I know we're how long we're here. We're only 36 minutes, so we're 3/4 of the way through, so we won't take a break. I'll just wrap this up for you. Okay. I'm sure you have no objections to getting out a little bit earlier today, given the fantastic day that we have in weatherways. But here we have, as you can see up here, the different levels of a tree-based plant. So here's your bus, a toy bus, and we break it down into the case label, the toy bus package itself, and the packaging case. And then we have the bus box, and then we take the toy bus itself and we break it down into the body, and then we break the body down into the plastic parts that are needed, and so on, and keep breaking it down onto the plastic powder and the plastic dye in black to make the individual components before we assemble it. So you can see we have, in this case, 6 levels of breakdown, and you that's another way of identifying the bill of materials. So we can put costs onto each of these. How much does a case cost, and how much does the case label cost, and so on. So we get a breakdown of the cost structure as well as the physical activities or components that are needed. And then we just put how long does it take us to do the plastic powder. That might take 1 day, and then to do the plastic dye in black, that might take a day and a half. So now we can put a time on each of these activities. So we have a time and a cost. What's the cost? The cost could be, if we say it takes 1 day of 2 people and we pay them 50 euros a day, so that's 100 euros. That's known as the man-hour cost. If they're working 50 euros per day per person, divided by 8 is 6.25 or something like that, 6.15 euros per hour, if my maths are correct. So that's the man-hour cost of doing the plastic powder. Okay. So the work breakdown structure is the product-oriented family tree subdivision of hardware, services, data required, and so on. So breaks tasks down into successively finer levels of detail, which we showed in the previous diagram. And this continues until all meaningful tasks or work packages have been identified. Now, you wouldn't be breaking it down into the actual screws that are needed. That doesn't make sense. But if you have, if you're making one part of the component, or in this case the bus, you might say, well, we need 4 screws, we need 2 labels, we need this, that, and the other thing. That's the work package. One person puts all this together. That's the work package. As I say, down to the level that makes sense. So these smaller elements make tracking work easier. So need separate budget schedule for each task or work package. So that's when we have it down to that level of granularity, that micro level. Then we know that Mark is working on that part of the bus. He'll spend a day there, and then Sandra is working on that part of the bus. She'll spend a day and a half there. So now we have the activities assigned. Now they could be working at the same time. Mark is doing his part, Sandra's doing her part, and Dave is doing another part, and so on. So we have those work packages, and we have people assigned to it. So everything is planned. So the steps we use to create these work breakdown structures, okay, to break it all the ways down. List the task breakdown in successive levels. So keep going down, breaking down the levels. That's why you have project manager with the technical people, because they'll understand what makes sense in terms of the work breakdown structure and what the packages are. In order to say, you don't need to go down to that level and on that package because it doesn't make sense. They're the screws, they're the bits of wire. We don't need to know that level. We know that all these elements are used to make this part of the product or component. Identify data for each work package. So what's required, essentially, how we're going to track that work. Review the work package information, cost of work packages, scheduled work packages, and then continually examine actual resource use, and then continually examine the schedule itself. Bottom 2 points, monitoring and control. But scheduled work, so we'd say that for Mark now at 9 o'clock on Tuesday morning, you're going to spend an hour and a half working on that part of the package, and so on and so on. And here's an example of a visual breakdown structure. I just need to put this. Oh yeah. So a conference. So we have to have the location. I'm pointing at something. You can't see what I'm pointing at. You're trying to organize a conference at level 0, and there you have, let's just say it takes 10. Let's look at the numbers here. There could be time. There could be 10 hours to do, for in total, or 10 days to prepare for this conference. Location might be, that doesn't make sense to me. Oh, these are just the numbers of the activities, so 10 and 11. And in item 11, you have 11.1 and 11.2. And in the facilities, you have 12, which is item number 12 here. And then 12.1.01.02, 3, and then you have 0, 1, 2, 3. So each of them are broken down. Do you follow that hierarchy? It's pretty straightforward, I think. And then, so a linear responsibility chart ties each work package to somebody. Already spoke about that. Activity, person, activity, person. And may show hierarchy, show interfaces between groups. So if I do a particular activity, I have an output. It might be part of a component or a component. Then that goes to another group, and it goes to another person. So and they add to it, and so on. And this is just another way of showing a sample linear responsibility chart of who's doing what to various components. You can ignore that. That's all done automatically nowadays. We never use those charts, to be honest with you. Interface coordination through integration management. So managing a project requires a great deal of coordination. That's why you're highly paid as project managers. You're good at coordinating. So projects typically draw from many parts of the organization as well as outsiders. So you may have subcontractors, you may have to contract in specialists and so on. So you need to pull it all together. That's your job. You're the conductor of the orchestra as a project manager. So all of these must be coordinated, conducted. And then the linear responsibility chart helps the project manager accomplish this. So when we know who's doing what, and we know that these are internal resources, these are external resources, we need to coordinate with the external resources, that they come into us and are available at the right time when we need them. We don't want external people sitting around until the work is ready for them to do. Coordinate them when they come in. Integration man. So multidisciplinary teams, which are again, engineers, business, marketing, so on. You'd have different types, product designers, all these different elements. HR, for example, finance, they can all be different teams working together. Or you might have subgroups of teams. You might have a product engineer and a marketing person working together, and a design engineer as a small subgroup, because they want to come up with a solution for a particular part of the project, and so on, and how they interface. Why this coordination and the interfaces, why these become important, when you have the activities assigned to a person level. That's all very fine. It's what happens then after that. So making sure that the deliverables that my output goes to the next person or the right person in the sequence and so on. Many years ago, when I was in software engineering and writing program code, the coding part was the easy part. But each piece of code that we wrote, we could have, 8, 9, 10,000 lines of code, which doesn't sound like a lot, but they were complex. So we would get information from another piece of code. We refer to our programs as blocks. So you'd have so many blocks of code programs, and information was passed from one block to another from different blocks and coming across. So when we were developing the code, we always had to look at what was coming in and what was going out, and then we'd work our code to be more efficient and to add new features, to change data and push it out differently and so on. So we always looked at the interfaces, as we call them, the signals in actual fact. And so we had to be careful that what we're sending out, because other users might have to use the same data, and we have to avoid corrupting it or adding to it and changing it to that other users couldn't use the signal data. And that's where, from my programming days, it made an awful lot more sense in terms of project management coordination. And lastly, you'll be delighted to know, managing project by phases and phase gates. So break the activities down, and you have the project lifecycle used for component parts, for example, or focus on specific short-term outcomes or lots. So all that is in that descriptor of the Meteor methodology, your toll gates. So you have phases and sub-phases or steps with milestones inside. That's all this is telling you in this case. So that was your project planning and group activities, as we call it. Let's close that down there. And we're back to where we started. So folks, that was a whistle stop tour. 2-hour lecture done in an hour. Do you have any questions?
I just have a question about, do you know when, or do you have the other things corrected, the things that we sent you?
Not yet, Dave. No, I will probably get to them over the Easter period. During my Easter holidays, I will be doing all of that work. It's just we're pretty flat out at the moment with we have program boards and all this sort of stuff coming up, and new program submissions, and God knows what else is going on for the remaining 2 weeks, because there's not really a lot happening after Easter as such. Just when you think it's winding down, it's actually winding up for us. So I look at these over the Easter period and get them wrapped up for you. Yeah.
All right, cheers, thanks.
Okay, folks, I won't hold you then. I'll let you. It looks like a fabulous day outside there. I'm not going to get to see much of it, but you might as well go out. If you have no more lectures, take advantage of it and get some fresh air and enjoy it. It won't last forever. And I won't bring you in for a lecture on Thursday. I'll record the next one in sequence. Just let me double check which one it is. Where did it go on me? I had it set up here. Presentations, notes, and I go down to here. It was. Oh yeah, here. I'll do a quick overview of the costs and budgets. That's the next one, and we've pretty much covered all at that stage. I'll have a look. Yeah, I will come back next week and look at finally controlling and evaluating projects themselves, and that's pretty much it then. We'll as well as talking about the final assignment as well, and yeah, we'll let you down gently, as I say. So I'll record the next lecture for Thursday morning, and you can look at it at your own leisure. Just by the way, I do look at YouTube, and I see very few people using the material or even looking at the material. Don't quite understand why. Do you all have access to YouTube? Yeah. Okay. But in any case, those lectures that I don't give live are recorded on YouTube, so I would imagine that you're looking at them, or at least I'm not imagining you're not looking at them. Not everyone. So I suggest you do so. It's for your benefit as much as mine to get the material covered for you. All right, folks. I'll let you go, and we'll talk to you next week, please God. All right?
Cheers.
Thank you.
Okay. Take it easy.
Bye-bye.
Thank you.
Bye bye. Bye
Thank
bye.
you.
You're
Thank you.
welcome.
Bye.